What is up, nerds? The Mortal Nerd here, and welcome back to my first channel. I know it's been a very long time, and that's because I've been putting that into my anime channel. A lot of stuff been going on there. A lot of new shows are coming out for this fall. Some look very interesting. I may give those a look at. But there are other shows that I have not watched that have been out for a couple of years, like Tokyo Ghoul, Psycho Pass, and the new season for My Hero Academia that finished a couple weeks ago. So I'll be getting into those first before the new shows. But that's neither here nor there. What I want to get into is now, before I start, you may be thinking, well, you got a anime picture up here, so why is this on your first channel? Well, that is because in this particular show, One Punch Man, the guy that you see here, is called Saitama. He literally, finished off his opponents with one punch. Now, this type of show is a satire, seinen type of anime show. So it makes fun of, different shows or things that are going on in the world. And so you can expect it to have some ridiculous stuff in there. And one thing in particular that a lot of people been asking about, in the last episode, he jumps from the moon to the earth in, fairly a small amount of time. And people wanted to know the force that he used to do this. So that's what I'm going to be doing here today. And I'm going to talk about some other stuff after I finish doing that. But as of right now, that's what I'm going to do. Figuring out just how much force did Saitama use to complete this feat. So, some things that we will need: the distance from the Earth to the moon. Now, I'm going to set off some ground rules here. They give you the average for the distance between the Earth and the moon from their centers. Now, with me being technical, Saitama is nowhere near the center of these two objects, so what I did was took the distance from their surfaces. I know it said it's all the same because it's average, but this is how I do my calculation. If you want to do it the other way, then you can make your own video. But this is how I'm doing it. So, easy way to get that is just take the radius or radii from these two objects and subtract that total from the average distance from their centers. And what you get is 3.76 times 10 to the 8 meters. I like to use scientific notation, so you'll see that a lot. Another thing that we will also need is his speed. Now, this was one of the things that was very critical on getting, because in anime and or manga, you can't do simultaneous events. So there were different numbers on how long it took him to reach from the moon to the Earth. So what I did was I took the averages of those numbers, and also I did some experiments, because in that scene with his opponent, when he's talking, he's not talking aloud, he's talking in his mind, and we tend to talk faster in our mind than out loud. So I did about 3 trials of that, saying his lines on how fast it would take me to do that, and took those into the averages as well. And the time that I get was 13.6 seconds. So that is the time that I will be using for just how long it took Saitama to reach the moon to the Earth. So I have that. Next that I will need is his mass. It's 70 kilograms. Another thing that I would need is the energy. And the reason why I need energy is because I can convert that to force by using 2 formulas. The first one, in order to get the energy, the kinetic energy formula, 1/2 times mass times the velocity squared. Then once I will have that energy, I will use the work formula. Work equals force times distance. I will have my 2 knowns, the work and the distance, and I'll be able to get the force. So fairly simple here. So when I do all of this, I have the distance, which I stated before. His speed, I would get that by doing the distance between the surfaces of the objects divided by your 13.6 seconds. And what I get is 2.76 times 10 to the 7 meters per second. So this is his velocity during that time. Next, I will need his I was going to say kinematic equation, kinetic energy. So 1/2 times his mass, which is 70 kg, times the velocity I just found, 2.76 times 10 to the 7 meters per second. And what you will get is about 2.67 times 10 to the 16 joules, or 26.7 pecajoules. Yeah, peca, P-E-C-A, joules. Now that is a unit that I have never used in any of my physics courses that I have been in. So just to see how much energy that is, 1 pecajoule is 1 billion cubic feet of natural gas. Now, those of us, we pretty much all of us in the world use natural gas, but we really don't think of, natural gas of, what is that in compared to anything else. So another perspective, 1 pecajoule is 1 million gigajoules. Okay. Now, an average well insulated home can be heated using 50 gigajoules per year. That's 1 pecajoule is 4 times that. And we got 26.7 pecajoules. Saitama can literally heat a home for a little over 100 years just from what he did there, doing that. That's beyond crazy. Like, that's insane. But anyway, that's just the energy. But now that we got that, next thing we would do is use the work formula. Solve for the force, so you'll have work divided by your distance. So our work here is the 26.7 pecajoules. And you're going to divide that by the distance between your two objects, the Earth and the Moon, which is the 3.76 times 10 to the 8 meters, which will give you about 7.10 times 10 to the 7 newtons. Now, I don't know if any of my viewers were alive during this time, but that's just a little over 2 times the thrusting power of Saturn V at liftoff. And if you weren't, I'm pretty sure majority of you weren't, you can Google that and just see just how much that was. Now, this is all, if you want to look at this as, an Einstein special general and Einstein special and general theories of relativity, it's not that it's I won't say a normal feat, because he's a human. And first of all, what human can survive in outer space, in the moon, more or less, just by holding his breath? No. But the feat itself, whether he's a human or a certain object, it's not impossible. It's very possible, because the speed that he's going, it's about 9% of the speed of light. And if you were to use the Lorentz factors for this, that'll equate out to 3% of time dilation or length contraction. If you ever took modern physics or whatever, you know what I'm talking about. But yeah, this isn't abnormal. For a human, yes, but for just an object, no. This is rarely possible. But like I said, as a human, no. But this makes sense, because this is, like I said in the beginning, a satire type of show. And the force that we calculated, it does make sense, because when he does this jump, he creates a crater in the moon. Like, yeah, you have to have a lot of force to do that. And like I was saying earlier, I was going to talk about some other stuff after I did the calculations. When people asked this question years ago, they were giving them an answer, but not the answer that they wanted. Like, they always gave them energy, or they were using something else to still give them energy, or they were making it more complicated, saying you'll need differential equations needing to know, uh, the exact rotation of the earth or whatever to land. Like, no, we can just make this an ideal situation. Let's say they were rotating. We can keep that, but they were where he wanted to jump from to where he needed to be was a straight line. So all he had to do was just jump, and there you go. Because Saitama, he's not that very bright of a person. He has some common sense, but that's just about it. So that's out the window. He wasn't a grad student that majored in astrophysics or whatever. No, he was looking for a job as a businessman, and he didn't even get that. So we know he wasn't that smart. But anyway, yeah, like I was saying, people, they were just giving them these complicated things, and the speed that they were using, they were always talking about the lunar escape velocity. I'm like, okay, yeah, let's use that. You plug that in and figure it out, and you will get a force that doesn't even come close to what we have here. The amount of force that they use, if you were using the lunar escape velocity, doesn't even come close to one. It's like 0.06, I believe, or 0.6. Yeah, that's not enough. That's not enough to put a crater in the moon. But I mean, you can still use that. You can still use that speed. I mean, that doesn't mean it's wrong. It's just wrong in this scenario, because if we did use this velocity here, it would have took Saitama about 9.5 hours, I believe it was, to make it back to the Earth. Now, I know, like I said before, in anime and manga, they can't do simultaneous events, but we know just as the next guy that nobody's gonna wait 9 hours for somebody to come back from the moon. We're gonna pretty much think that they're dead and just go on to destroy the Earth like they were planning to do in the beginning. But no, this was like a few good seconds. So yeah, so that couldn't have worked. So I made this video to really answer the question as best as I could with the numbers that I was given and some of my own, and average it all together to get the force. So those of you that have not gotten the answer that you really wanted, here it is. You are very welcome, and I was very glad to do it. I mean, you could have done it on your own. It was very simple. I mean, at first I thought it was going to be hard as well, because people, they were making it out to be hard, but I'm like, let's just set this up in an ideal system where not a whole lot is, we don't have a whole lot of variables. Just one straight line. He doesn't have to time, the rotation of both of these objects. No Coriolis effect or anything like that. No, just a simple system for us to work this thing out. I mean, if you wanted to figure out exactly what this was, then why don't you go to the moon and make that feat? I mean, but all jokes aside, yeah, I really enjoyed doing this. I mean, it just shows just how crazy strong he is. But yeah, I hope you guys enjoyed this. Me putting the two things that I enjoy doing together, anime and math/physics. And if you enjoyed it, put down in the comments below, what should I do this for next? I mean, I'm all ears. And or if I just should do some regular physics problems, with statics, whatever, kinematics equations, stuff with friction or whatever, I'm all game. So yeah, I'm ending it here. Please like, share, subscribe. Get this out there to all the nerds in the universe, multiverse, and alternate dimensions. And I will see you, hopefully not 2 or 4 months from now, in the next video. The Immortal Nerd, signing off.